Alrighty, the final review, part 4, page 4. So, we are up to number 18, which is on the top of page 4. And what we have here is a temperature problem. C equals 5/9 times quantity F minus 32, where C is degrees Celsius and F is Fahrenheit. And you could use this equation to go back and forth from those to figure out what centigrade and Fahrenheit are equivalent to. In this particular problem, they tell us that F is 95. So your job is to stick that 95 right into the F spot. So let's do that. Boing. So this used to be F. And now we put 95 in its place and just work it out. Order of ops. Do this stuff first inside the parentheses, and that gives you 63. Bring down the 5/9. That's multiplied. And C is equal to whatever this is. So 5/9 times 63, put it over 1. Does anything cancel? You betcha. The 9 goes into 63 7 times. So then what you get is C is equal to 35 over 1, which is just 35, and that's degrees Celsius. And there you have it. Not too bad. Okay, next up is number 19, where it's one of those ratio proportion type problems where they say in 4 hours, that's what it takes to type 12 pages. So how many hours would it be required to type 21 pages? There's a few ways to do this. Best way I think is just to set it up. And let's just, make ratio. It's 4 to 12. And I think it helps to do 4 hours to 12 pages. Actually write the units in. Now we're going to do this as a proportion method. Different from unit conversion. We say, well, 4 hours for a 12 page, then how many X hours are in 21 pages? And how do you find X? Well, the easiest way when you get a fraction equal to a fraction is just to do that cross multiply thing. So I'll do the X side first. So you get 12X equals 4 times 21. So 12X equals 84. And wouldn't you know, you divide both sides by 12. Okay, let me write it over here. When you divide both sides by 12, amazingly enough, you get X is equal to 7. And this is 7 hours, because that's what we tried to find. That's it. That wasn't so bad. Another thing to realize is you could have looked at this thing over here and said, oh, 4 hours to 12 pages, that's the same as 1 to 3. 3 pages in an hour. There's lots of different ways you can flip the fractions over as long as you're consistent. Hours to pages, hours to pages. Now I just reduced that to 1 hour for 3 pages. So 21 pages, well, how many 3's go in there? 7. I mean, you can get it that way too. It's all good. All rooms lead to roads. No, all roads lead to Rome, they say, and we're roaming around on this algebra problem. 20 on the way. 60 students in Jose's class. That's a lot of people in the class. 3/4 of those students are science majors. How many students are science majors? So basically, this is 3/4 of 60, straight up. And what does that mean? It means 3/4 times 60 over 1. And that'll work. It's going to be more than half, so more than 30. But what is 3/4 of 60? Do it like so. Just multiply 3/4 times it. You can do a little cancel-y poo. How many 4's go in there? 15. Cool. So then what you have left is 3 times 15 over 1, which equals 45. And we're talking what? 45 students are science majors. in this particular class. That's the deal. Alrighty, now we're jumping into factoring. This one's kind of interesting because there's no squares in it. So 3s plus 9 plus 60, those don't go together. You can't reduce it or simplify it anymore. But you can pull out a common factor. And look at what these guys got. A 3, 9, and a 6. The t and the s don't help. That guy in the middle is just a number. But we can break out as 3 from all those things. So what you do is you pull the 3 in front. It's like you're dividing it out. And it's really distributive with division. So it's 3 into 3s. What's left? The s. 3 into 9. You can put the 1 in front. That's plus 3. And then 3 goes in 60. Tutti. That's great. Except for my s looks like a 5. I'm going to get rid of that 1 in front just because I don't like how it looks. But there's your answer. And then you can always check it by doing the... Does it distribute back to the beginning? Sure does. So there you go. Next up is something slightly more dense. 7x squared minus 21x. Can you factor that? Factor, factor, factor. Factor means break it down to things being multiplied. I'm looking at that and I'm seeing 7's right in front. 7 goes into that. So let's pull 7 out for sure. But, excuse me, that's more. There's more you can do than that. You can, you can pull out the 7 and looking at the variables, I can take an x out. No more than 1 because that's all this guy has. But let's pull an x out too. And let's see what's left. So if you pull a 7 and an x out of this guy, 7 comes out, there's one left in the middle. How about over here? Sign's the same. 7 goes into 21 3 times, and the x is covered. And if you're not sure, you can always just go and see if you get back to where you started from. That makes 7x squared in the front minus 21x. That's it. So it must be good. And that is your answer. So that's a nice job of factoring. That's factoring, common factoring. So that's cool. Alrighty. We're done with the 4th page, just like that. That's nice. Alright. Let's end this one and then start up number 5. See ya.